Yeah, okay. Let's just move on. So we have been dealing with your third unit. Okay. So the third unit we have been seeing about the generation. Okay. So the generation of your high voltage. Okay, we have been dealing with. So in that we have completed your generation of your DC voltage, followed by the generation of your high AC voltage with respect to your power frequency. Okay. So in today's class, what we'll be dealing is we'll be dealing with high AC voltage with very high frequency. Okay. So in terms of your what you can say uh, utility power grid or your domestic purpose grid, you'll be making use of your AC voltage in your 50 hertz. This is nothing but your power frequency. But today, what we'll be seeing is how to generate a very high AC voltage when the frequency is higher. Okay, so that's what today we'll be seeing. So that's what it's given in a lecture for. Okay. So today I'll be also accompanying you with some examples in terms of your real life. Okay, how you can generate like that. So first, so the lecture objective is to generate a high AC voltage in terms of the high frequency. So the method for this which is used will be your Tesla coil. Okay. So this Tesla coil was founded by none other than Nikola Tesla. So who was a pioneer in your electrical in the late of 90s, and he was the one who was the starting point for your wireless transmission. Okay, so we'll be dealing with that. So first we'll be getting into the lecture, the generation of high frequency AC supply. So that's what all we'll be seeing in today's lecture. So first, similar to the previous lecture, you have to know about the need. What's the need for going for a high frequency AC supply? So it is required for generating high DC power supply. Okay. So with respect to this, I'll be saying the afterwards. The main thing is that Tesla was the one who was concentrating over the DC quantity. Okay, but Edison was the one who was concentrating over the AC quantity. So Tesla was saying that your transmission in terms of your DC will be more efficient than your AC supply. Okay. So for in order to generate and transmit such kind of very high DC power supplies, you need a very high AC supply. Okay. For testing electrical apparatus for switching surges, high frequency, high voltage damped oscillations are needed. Okay. As I said, similar to the previous lecture, for the testing purpose, also we need a very high AC voltage. Okay. So generation, so how it can be generated is that high frequency AC supply can be generated using a high frequency transformer. So the for generation of a high frequency supply, you need your very high frequency transformer. Similar to the previous question will also will be making use of the transformers, but those transformers and all will be rated for your power frequency supply. So the power frequency supply for 50 hertz. But over here, these high frequency AC supply generated will be through the transformer with a very high frequency. Okay. So over here, the primary and the secondary windings are wounded on a insulated with no core. So generally, you are similar to your uh, solenoid concept. That is, in the solenoid, there will be a core, but over here there will not be any kind of core. It will be the air is be acting as a dielectric medium, and your air will be a the core. Okay. So the advantages of this is that due to the absence of iron core, okay, in the transformers, the saving is in cost and price is possible. The second one is the pure sine wave output can be got. The slow buildup of voltages over a few cycles and hence no damage due to the switching surges. Okay. So moving on. So this can be generated with the Tesla coil. So I'll be just giving a glance about the theoretical part. The practical part, I'm having a video. So I'll be playing that video at the end. Okay. So to generate a high frequency AC supply, Tesla coil will be making use. So over here, the main concept is based upon the principle of resonance. Okay. So this resonance is got by a double tune circuit. Okay. So that is there will be, as I said, for the resonance to happen, your inductor frequency must be equal to that of your capacitor frequency. So if you are achieving that means your circuit will be in the resonance part. Okay. So here what happens is that the supply will be given. Okay. That is, for example, 120 volt supply might be given. And this 120 volt supply will be given to the spark gap. So regarding spark gap, I'll be telling in the upcoming class. But this spark gap, you just have in mind that it is similar to that of a capacitor. Okay. So here what happens is that it gets charges and then it discharges through this circuit. And in the duration of resonance, okay, this circuit, that is C1 L1 circuit, will be in resonance with the L2 C2 circuit. Okay. So due to this, a very high frequency voltage with a very high amplitude will be formed. Okay. How it will be formed is given in the expression. So this is the analysis part. So this analysis part you have to see through, but these are the important equations. So what they'll be doing is normally they'll be applying KVL over the primary loop and then the KVL over the secondary loop. Then they'll be connecting both these things with your mutual inductance concept. Okay. So this is what it happens. So if you are applying KVL in the primary loop means it will be V1 1 by C1. So from the time period 0 to T. So with respect to your self-inductance plus your mutual inductance they have given. So then you have to apply your Laplace transform. So in terms of your secondary coil, there won't be any kind of the voltage drop, because in the secondary there will be only the voltage rise. Okay. So the voltage drop will be at 0, and again you will be making the Laplace transform. Okay. The output voltage across, that is we need the output. The output will be given with this expression. So from that, you have to apply these two from the first and second equation. You will be applying, and you will be getting the V2 in this format. Okay, this is a simple simplification only. Okay, so and they'll be taking each and everything with respect to your constants. Okay, so over here K will be equal to the coefficient of coupling. This you already know. So the peak amplitude expression they have given. So this and all expression you can just learn it out by yourself. Very simple expression only. And this question also derivation is possible. They will be asking. Okay. So in general, okay, from this Tesla coil, what can be inferred? If you are seeing me, a more simplified analysis for the Tesla coil can be presented. How it can be presented by considering the energy stored in the primary circuit in capacitance, C1 is transferred to the C2 via the magnetic field. So here the analysis, in simplified analysis, they will be taking with respect to the energy storage. Okay. So the energy storage W1 will be the energy storage in C1 and W2 will be the energy storage in C2. So both the energies will be, if you are coupling together, that is in resonance, what happens is that as I said, your frequency will be the same. Similar to that, the energy generated over at the primary circuit will also be equal to that of your secondary circuit. So in such case, the energy storage stored will be the same. So half NC1 V1 square will be equal to half C2 V2 square, and so you'll be getting for the output voltage as V2 equal to V1 N C1 by root of C1 by C2. Okay. So this is a basic explanation. Okay. So in general, where they have been, so the possible question over here is the need for usage of high voltage AC and then the analysis of Tesla coil. These two are the possible questions. But where they'll be mainly using these kind of high voltage, high AC means mainly at the terms of your DC, that is for wireless transmission. Okay, recently New Zealand has achieved these kind of wireless transmission. So for the wireless transmission can be achieved through these kind of Tesla coils. So the voltage which is produced will be in terms of kilovolt. So at the receiving side, you can capture the wireless energy, okay, and there won't be any kind of losses also. Okay, so I'll be just showing you the video with respect to your Tesla coil, okay, and you'll be getting a clear cut idea about the Tesla coil. Okay, so I think the sound will also be audible because I'm playing it through my mobile phone. You can just test it out. And yeah, so I have also given the YouTube link with for this. Okay. Yeah. So is the video audible to you? Is the video audible to you? Okay. Wait. Just. Okay. Okay. I will be just making through the system. So whether is it audible? Otherwise, you just see through the captions. Okay. I'll be just turning on the caption. Is it audible to you? Otherwise, okay, fine. I'll be just turning upon the. I'll be just turning out the captions. You just keep through it. Keep through the caption. Okay. Okay. You will see through the caption, and I will also be explaining about it. So this is the coil which is the side of him is nothing but your Tesla coil. Okay, it was built by him. Okay, so for a smaller voltage range. Okay, so he itself built this coil. Okay, so here you can see. So this is the coil, and it is bringing out the arcs. Okay, so it is bringing out the arcs. So here you can see that he have used Tesla file, and the operating also he have given out a little bit. So as you can see, what he said was during the time of resonance. Okay, during the time of resonance, it is possible for you to generate such a very high voltage. Okay, so he had the what we have seen in the equivalent circuit, and he have shown that in the video itself. Okay, so I have also given out another one video for your understanding. That is, he even burnt pine tree with the help of that Tesla coil. Okay, so you just see through the video. Okay, and you'll be getting somewhat more clear idea regarding this. So, and I think after seeing the video, you might have got some clarity regarding your Tesla coil. Okay, so with this, we can